WPR number 9. Question 1. P and Q vary inversely. That means that their product remains constant. That's a property of inverse variation. So when P is 25 and Q is 6, their product is 150. And if P changes to 30, we can find the new Q value because 30 times the new Q value must still be 150. Dividing both sides by 30, we get 5. Because 30 times 5 is 150. Notice that in an inverse variation, as one variable gets bigger, for example, P increases from 25 to 30, the other value gets smaller. The Q value decreased from 6 to 5. Question 2, express in simplest form. Well, this is really a division problem. I'm going to keep, change, flip. So I'm going to keep this numerator, change to multiplication, and flip the denominator. And as I do so, I'm also going to rewrite by factoring. So the 36 minus x squared, I can rewrite as 6 plus x and 6 minus x. The x plus 6 squared I can rewrite as x plus 6 times x plus 6. That's the keep part. I'm keeping this the same. It really is the same. I've just factored it. Now I'm changing this to multiplication from division. That's the change part of keep, change, flip. And now I'm going to flip this. As I flip it, I'm going to factor. So the x minus 3 will flip into the denominator. There's nothing really to factor there. But the x squared plus 3x minus 18 can be factored into x plus 6, x minus 3. Now all the factoring's done, and before I multiply the numerators together and the denominators together, I can reduce. So this x plus 6, and it really is an x plus 6 because you can switch terms around an addition symbol without changing its value, would reduce with this x plus 6, and this x plus 6, and this x plus 6 also reduce. These x minus 3's reduce. Everything's a 1 except for the 6 minus x. In the numerator, it's 6 minus x over 1, which is just 6 minus x. Anytime we're asked to find the probability that something occurs exactly, at most, or at least a number of times, we use this formula. So if we see the word exactly or the phrases at least or at most, we use this formula. Where n stands for the number of trials, r stands for the number of successes, s is the probability of success, and f is the probability of failure. In this example, we see Ashley being a catcher as success. And we would like her to be catcher 5 times. The team is playing 6 games. That's the number of games or number of trials, and we would like her to be catcher 5 times. Because we see Ashley playing as a success, the probability of success would be 2 out of 5. Failure is when Ashley doesn't catch, and if she's catching 2 of the 5 games, she is not catching 3 of the 5 games. So there are 6 games that Ashley's team will play. We're choosing for her to catch in exactly 5 of them. The probability that she catches in a game, or the probability of success, is 2 out of 5, and we would like her to be successful 5 times. The probability of failure would be 3 out of 5, and if she's going to be successful 5 times out of 6, she's going to fail once out of 6 times in being the catcher. This would be the setup, and we can plug this value or this expression into our calculator to find the probability. I write the entire decimal down, 0.036864. If we were to express this as a percent by moving the decimal point 2 places to the right, it would be 3.6864%. The question didn't ask us for that, but I'm just pointing out that that's about 3.6%. Less than 4% of the time would we expect Ashley to catch 5 out of 6 games. It's not very likely. We use the bell-shaped curve to answer questions about normal distributions. This line is this value that represents the mean of the set of data, also called x bar. In this example, there's a test that has a normal distribution of scores, and a 57 falls 1 standard deviation below the mean. I'll call this x bar minus 1 standard deviation. And that's a value of 57. We're told a score of 81 is 2 standard deviations above the mean. So x bar plus 1 standard deviation and x bar plus 2 standard deviations. 2 standard deviations above would be a score of 81. So the distance from here to here is 1 standard deviation, and the distance from here to here is another one, and the distance from here to here is another one. So the distance from 81 to 57 would be equal to 3 standard deviations. Let's see, 81 minus 57 is 24. So if 24 is 3 standard deviations, that would mean 1 standard deviation is 8. So if I were to take the 57 and add 8, I would get to my mean. 57 plus 8 is 65. Or if I were to take 81 and subtract 8 twice, or subtract 16, I would get 65. The mean is 65. You can perform an exponential regression on your calculator by typing the years after 1990 in the first column, called X, and the amount in the second column, called Y. Then you go to your menu and you go to your Stat Exponential Regression. Now the question asks you to write the equation, and a mistake that a lot of students make is that they don't write y equals. They have this just fine, but they don't write y equals, and without that it's not an equation, so make sure you write y equals. Also, you don't have to make a point of explaining what the variables are. I'm just doing that to help you with the next part of the question, which is to use the equation to determine the amount of the substance, so we're trying to find y, that remained in 2002. So we're going to put a time in for x. The question is, what time will we put in? Well, y is equal to 733.646 times 0.786 to the power of, but we do not put 2002 in for x because x is defined as the years after 1990. To figure out how to do this, let's imagine if the year is 1991. How many years after 1990 would that be? It would be 1 year, or 1991 minus 1990. So to figure the years after 1990, we subtract 1990 from the value that we're given. 2002 minus 1990 would be 22. So I'm going to go ahead and type this in on my calculator, and there are separate directions for rounding this answer. We're supposed to round to the nearest integer. To the nearest integer, the amount would be 4. Question 6. Use the recursive sequence defined to express the next 3 terms as fractions reduced in lowest terms. Well, we know the value of the first term is 2. According to this rule, to find the value of a term, we take the value of the term that comes before it, raise it to the power of -2, and then multiply it by 3. Couple notes here. First, n is the number of a term. N minus 1 would always be 1 less than n. So whatever term number we're talking about, this would be 1 less than that, which means a sub n minus 1 will always be the value of the term that comes before a sub n. So if we're trying to find the value of the second term, that means this is 2, and this would be the value, this would be 1, and we'd be finding the value of the first term to plug in here. So we'd have 3 times 2 to the power of negative 2. That would be 3 times 1 over 2 to the power of positive 2, which would be 3/4. So the value of the second term is 3/4, and according to the rule, we will then take that 3/4 and use it in here to find the value of the next term. So the value of the third term would be 3 times the value of the second term, which is 3/4, to the power of negative 2. Again, we do exponents before multiplying by 3, so this will become 3 times, and in the previous example, we found 2 to the power of negative 2 by simply finding the reciprocal of 2, which is 1/2, and raising it to the power of positive 2. We took the 2 and we turned it upside down and made the exponent positive. We're going to do the same thing here. We're going to turn this fraction upside down and make the exponent positive. So 4/3 to the power of positive 2. And now to raise a fraction to the power of 2, or to square a fraction, you multiply the numerator by itself and the denominator by itself. I can reduce this to get 16/3, which means the first 3 terms are 2, 3/4, and 16/3. I have 3 terms, but I have to be careful because the question asks me to find the next 3 terms. So I'm not done yet. To find the value of the fourth term, according to the rule, I'm going to take 3, multiply it by the value of the previous term to the power of negative 2. So I have 3, and now I'm going to take that fraction and turn it upside down to make the exponent positive. And now I'll have 3 times, well, 3 squared is 9. And 16 squared is 256. I know that 3 does not divide evenly into 256. So my answer will be 27 out of 256 for the value of that fourth term. For this graph, the maximum value is 4, and the minimum value is negative 2. So my formula for A is max minus min divided by 2. So it's going to be 4 minus negative 2 divided by 2, which would be 4 plus 2 divided by 2, or 6 divided by 2, which is 3. So the A value is 3. B is the frequency. The formula for frequency is 2 pi over the period. Looking at this graph, I see that it has a peak at negative pi, and it peaks again at 0, and the distance from negative pi to 0 is a distance of pi. And so the frequency is 2, which means there will be 2 full cycles between 0 and 2 pi, which makes sense because when I look at the graph, I see a full cycle of this graph between 0 and 1 pi, so there must be 2 of them between 0 and 2 pi. C is the max plus the min, or 4 plus negative 2 divided by 2 still. It's the max plus the min divided by 2, so 4 plus negative 2 divided by 2 would be 2 divided by 2, which is 1. Now we have to decide if this is a sine or a cosine graph. Notice at 0 it does not start at y having a coordinate of 0. It starts at its high point of 4. So this is a cosine graph because it doesn't start and finish on its midline. So we could say the equation is y equals a cosine of bx plus c. This graph is y equals 3 cosine 2x plus c.